This presentation is about data preparation. In this presentation, I will start by analyzing the problem of data preparation, and I will focus especially in missing values, normalization and standardization, then gamification, and finally data balancing. Data preparation is the process of cleaning and transforming raw data before processing and analysis. It is an essential step before processing and often involves reformatting data, making corrections to data, and combining data sets to enrich data. Data preparation is often a lengthy undertaking for professionals involved in this area, mainly data scientists and also business analysts. However, it is essential as a prerequisite to put data in context, to turn it into insights, and eliminate bias resulting from poor data quality. So, in this context, we may identify as possible examples of data preparation, standardization data formats, enrich source data, and removing outliers. In order to fill null values in a dataset, we may use the following functions: fill NA, replace, interpolate, and these functions may be useful, for example, to replace not available values with some value of their own. Here I show a small example where the not available values are replaced by 0. We may also have other alternatives. For example, in this example, the first line allows to fill missing values with previous ones. The second will allow us to fill null values with the next ones. And obviously, we may also change, replace, for example, the not available by no gender in the case of genders. Fill all the news values with the means. This is the first expression. In the second, we are going to replace all the not available values in the data frame with minus 99 value. And you may also use the interpolate function to fill the missing values using a linear method. You may also drop missing values using dropNEF function that drops null values from a data frame. These functions may drop rows and columns of data sets with null values in different ways. For example, the first two, the second line allows to drop if all values in the rows are missing, and in the third line we drop columns with at least one null value. Here it is a small complete example where the missing values are replaced by means. Normalization is used to scale the data of an attribute so that it falls in a small range, such as -1 to 1 or 0 to 1. It is generally useful for classification algorithms. It can only be applied to numerical data without any missing values. Standardization is the process of putting different variables on the same scale, and this process allows to compare score between different types of variables. Typically, to standardize variables, you calculate the means and standard deviation for a variable. The purpose of dummification it is to create dummy variables. Of course, suppose that we have the following data set corresponding to grades of a specific course. We have the get dummy that will split the initial variable in several variables. We may use the function and then add back the dummy to the initial data. Data imbalance usually reflects an unequal distribution of classes within a dataset. For example, in credit card fraud detection dataset, most of the credit card transactions are not fraud, and a very few classes are fraud transactions. In the case of binary classification, we have positive to minority class and negative to minority 1. Typically, we have two different strategies, undersampling and oversampling. With a huge data set and consequently considerable number of positive records, undersampling strategy consists of keeping the positive records and sampling the negative ones to balance the final distribution. In the presence of a small number of positive records, we use oversampling in order to create a large set to support the training step. Smooth is a type of data augmentation for the minority class and is referred to as the synthetic minority oversampling technique, or obviously SMOOTH for short. Adaptive synthetic sampling, or ADASYN, is another approach that involves generating synthetic samples inversely proportional to the density of the examples in the minority class. That is, generate more synthetic examples in the region of the feature space where the density of minority example is low, and fewer or none where the density is high. This modification to SMOOTH was proposed by Haibo in 2080 in a paper named for this method, ADASYN, Adaptive Synthetic Sampling Approach for Imbalancing Learning. Summarizing, we analyzed the problem of data preparation. We analyzed missing values, normalization and standardization, dummification, and also data balancing.